Here we're going to look at two compound interest examples. Remembering that the amount that an investment grows to after T years is equal to the principal invested times 1 plus the interest rate divided by the number of times it is compounded per year times that same value, the number of times it's compounded per year, times the number of years. And so in the first example, we have $2,500 invested at a rate of 6.5% per year, compounded daily, and we're to find the investment after the amount that the investment grows to after the given number of years. So first of all, we'll be using 0.065 for R. We'll use 365 for the number of times compounded. And we're supposed to find the amount, first of all, after 3 years. So we'll have A of 3 equals 2,500 times 1 plus 0.065 divided by 365, all raised to the 365 times 3. If we go to the graphing calculator, we enter 2,500, open our parentheses, 1 plus 0.065 divided by 365, close the parentheses, caret, and then in parentheses 365 times 3. And it looks like we're getting $3,838.22. So 3,800, and now I forgot, I think it was 22. 3,038. I'm sorry. So $3,038.22. All right, so for 4 years, we'd have the amount after 4 years, everything would be the same. Except we'd have 365 times 4. So when we go to the graphing calculator, if you go second enter, it will bring the previous formula back. Now we can use the back space twice and type 4, and then we can hit enter. And we get $3,242.25. 3,242. and 25 cents. And one last time, we can go second, enter. Whoops. I'm going to do second quit. Somehow I got into the y equal screen. So now I'm going to go second, enter. I'm going to go back to enter 12, close the parentheses, hit enter, 5,453. $0.30. So that is A of 12, which was 2,500 times 1 plus 0.065 over 365 raised to the 365 times 12. Now we'll go to another example where instead of having daily compounding, we have quarterly compounding. And so this time we'll have A of 3 equals 4,000, which is the principal invested, times 1 plus 0.0575, which is 5.75% as a decimal, divided by 4, because we're looking at compounding quarterly, raised to the 4 times 3, or 12. When we go to the calculator, let me clear what we have there now and enter 4,000 times parentheses 1 plus 0.0575 divided by 4, close your parentheses, raised to the power, and I'm going to put it in parentheses 4 times 3. And we get 47.25. For 5 years, we'd have 4,000 times 1 plus 0.0575 all over 4, raised to the 4 times 5. Go back to the graphing calculator, do second enter, go back 1, 2, change the 3 to a 5, press enter, 53.2146. So $5,321.46 is the amount that the 4,000 grows to after 5 years when compounded quarterly. And lastly, we'll do the amount after 7 years. Second enter. I'm sorry, I made the same mistake that I made earlier. I'm going to go second quit and do second enter. Go back to, change the 5 to a 7, hit enter, and I get 59.65.12. 59 69.12. Let me confirm that. It was 65.12. So I will fix that. $5,965.12 is the amount after 7 years.